Natural selection is the process whereby individuals who are better adapted to survive in their environment will live longer and produce more offspring. And so through natural selection, there are three basic forms that natural selection takes when sculpting a population of a species: directional, stabilizing, and disruptive. A good example for directional selection would be the giraffe. So giraffes have their classical long necks like that, and they basically evolved those necks to be able to eat leaves out of trees. So let me walk you through how that kind of works. So with directional selection, basically on the y-axis here, we have the number of individuals, and on the x-axis down here, we have neck lengths. And so essentially what we see is from short to long, there's about less individuals with short necks and less individuals with long necks, and the majority of individuals have a medium-sized neck here. But so what happens is, with directional selection, there's basically a pressure that pushes this bell curve one way or another. Since giraffes are wanting to eat leaves that are in higher trees and outcompete each other for those leaves, the pressure is going to favor longer necks. So then it ends up looking something like this. So over many generations, the average neck length increases, giving us those long necks of giraffes that we see. Giraffes with shorter necks will not be able to get as many leaves as the taller ones, therefore the taller giraffes will be able to eat more and reproduce more, causing that directional selection to happen. Wow, I really wish I could reach those leaves. They look tasty. Guess I'll just die. Yeah man, this stuff tastes good. I'm so happy I have a longer neck than you and I can reach it. I'm gonna have so many babies. Now, there's also something called stabilizing selection. A good example for stabilizing selection would be tail length in a cheetah. So when cheetahs run, they have this long tail that goes out behind their body, and that basically works as a counterbalance. Since they're running so fast and have to be so agile to get prey, that tail is used to balance them, make sure that they don't fall while they're running over 60 miles an hour in their sprint. So imagine there's a population of cheetahs that has normal tail lengths like this, really short tails like just a little nub, or tails that are twice as long as this. In this population of cheetahs, less individuals have very short tails and less individuals have very long tails. The average number of individuals has the average tail length. That tail length is ideal for running and getting prey. And so over time, stressors decrease the amount of individuals that have super long and super short tails, forcing the bell curve to narrow like this. So essentially, over time, less and less individuals with really long tails and less individuals with really short tails will exist. With a really long tail, it would most likely just be dragging on the ground while you're running, and that would slow you down. And with a really short tail, you don't have the benefit of the balance that a medium-sized normal tail will give you. And that is why the average tail length for the cheetah is optimal, because it works as that balancing act for them hunting their prey. The third form of natural selection that I'm going to talk to you guys about is disruptive selection. A good example of this would be a subarctic environment where wolves are living. The wolves there range from white to gray to black. In this environment, it is very snowy, there's a lot of snow, but also patches of dark pine forest with a lot of cover and a lot of shadows, a lot of trees. So in this environment, being one extreme or the other is going to be very beneficial. In disruptive selection, it doesn't favor the average or the middle like in stabilizing selection. Instead, it favors both extremes. In this case, it would be very beneficial for you to be either a white wolf, so you can blend into the snow and snowy environment, or it would be very beneficial for you to be a black wolf and blend in very well with the shadows and darkness of those trees. And then gray wolves would become less and less common because they can't camouflage themselves in either environment as well as these guys can. The population, let's just say, starts out like this, the normal bell curve. The majority of individuals are gray, with some individuals being black and some individuals being white, but not as much as gray. So what tends to happen over time is the black and white individuals will be more successful, will be able to hunt more, live longer, reproduce more, so their offspring will increase in number, while the gray individuals will not eat as much, not reproduce as much, and their offspring will decrease, thus changing the dynamics of the population. Eventually the population would look like this, with a higher number of black-coated individuals, a higher number of white-coated individuals, and a lower number of gray-coated individuals. Hey, Al. Oh, hey, Tom. You seen Frank around? The gray wolf. I haven't seen him around in a while.
Yeah, pretty sure he starved to death. He couldn't blend into one of the extreme environments we had here.
Oh, that's a shame. He was a good guy.
Yeah, people kept seeing him because he was gray. He died.
Stabilizing, directional, disruptive.